Hi, today we're going to solve LeetCode problem number 136, which is single number, and it's an easy problem. The problem is, given a non-empty array of integers nums, every element appeared twice except for one. Find that single one. Here are some examples. Here's a list, and in the list we can see that 2 has appeared twice and 1 has only appeared one time, and that's our output. Here 1 has appeared 2 times. Same goes for 2, but 4 has only appeared one time, and that's our output. Here there is only one element, and that element is our output. So how are we going to code this problem? Let me explain what we are going to do. We have a list where every element is repeated twice, except for one. Our goal is to find that unique number, which in this case is 3. First, let's convert the list to a set. This removes all duplicates, leaving us with just the unique elements. Next, we'll sum all the unique elements in the set, which will give us the sum 10. Think of this as the sum of each element counted only once. Then we'll multiply that sum by 2, which will give us the result as 20. This essentially doubles the count of each unique element, as if we were counting them twice, then summing them up. Finally, let's sum the original list. In the original list, every number is repeated twice, except for 1, which is 3. This results in a sum equal to 17. Next, we will subtract this sum from the double sum we obtained earlier. So 20 minus 17, which will give us 3 as a result. I hope this makes sense. We can think of it as all the repeated numbers cancelled out. Since 3 was the only number not repeated, only one instance of the number 3 got cancelled out, and we were left with the another 3 as the final result. Let's quickly code this up. We can write a one-liner for this by first converting the list to a set. Then summing it up and multiplying it by 2. After that, we subtract this double sum from the sum of the original list. And we return it. Let's run it. It got accepted and all the 3 cases are correct. Let's submit it. And it's a valid solution. If we think about the space and time complexity, the space complexity is O of n due to the usage of sets. And time complexity is also O of n since we use the sum function, which internally uses a loop. Let's solve this problem using a different method. First, we will create an empty hash map, named hashMap, to keep track of count of each number. Next, we will loop through the given list of number. For each number, we will check if it's already in our hash map. If it is, we will increment its count. Otherwise, we will set the count to 1 since it will be the first occurrence. After this loop, our hash map will be fully populated with count for each unique element. Next, we use another loop to iterate through the hash map using the .item method. This method returns a list of tuples, each containing a key value pair, representing the unique element and its count. Inside the loop, we check if the count is 1. If true, we have found the unique element, and we return it. Let's submit it, and it works. This approach has a space complexity of O of n, as we are using a hash map, and time complexity is also O of n, as we are using loops to iterate. Now, let's see the most efficient way to solve this problem, which involves using the bitwise XOR operator denoted by the caret symbol. So, what's a bitwise operator? It's an operator used for bit manipulation, where bits are ones and zeros. There are some rules for using this operator. If we take two zeros and perform a bitwise operation between them, we'll get a 0. Similarly, if both inputs are 1, we'll get a 0. We'll get a 1 as an output only when these two operators are different, like in the case of 0, 1 and 1, 0. Let's take an example. The way to get a single number is by performing an XOR operation between all these numbers in the list. Let me explain this. For that, we have to convert these numbers into their binary representation, since we are using a bitwise operator. Now, we know that each number has a unique binary representation, and performing an XOR operation on the same number results in 0 because they share identical bits in same positions, so they cancel out, and honestly it doesn't matter in which order you perform the operation, as duplicate numbers always create an equal number of zeros and ones that cancel out using the XOR operator. At last we end up with a single number as a result, which doesn't have any duplicates. Let's code this up. First, we will take a result variable and its default value is 0. Then we will loop through the list, and inside the loop we will do a XOR of every element in the list, and we will store it in result. After our loop get finished, then we know that we have a single number and we return it. Let's submit it, and it works. The time complexity is O of n due to the loop, and for space complexity it is O of 1 since we only use a constant amount of space within the result variable. So that's it. See you in the next one.